Let's look at this problem. We're given this shaded area. This shape right here is defined by this equation, y squared equals to 1 minus x over 4. So from that equation, we can actually derive the equation for x. So if y squared equals to 1 minus x over 4, then x equals to 1 minus 4y squared. For this shape, we need to determine its centroid location, x bar, y bar. But we already know what y bar is. Y bar has to be 0 because this shape is symmetric. It is symmetric about the x-axis. Therefore, the centroid must be on the axis of symmetry. So the centroid C must be along the x-axis. We don't know what this is, but we know that for any point that is on the x-axis, the y-coordinate must be 0. So we only need to determine y bar, and y bar can be determined by this equation, integration of x tutor dA over the integration of dA. So dA is the area of the differential element that you choose, and x tutor is the x-coordinate of the centroid of your differential element. So for example, if I choose my differential element to be this little square right here, then its centroid location x is xy. Therefore, x tutor simply equals to x, y tutor simply equals to y. And this width right here is dx. This height right here is dy. Therefore, dA equals to dx times dy. But this way, I have to integrate with respect to two variables, x and y. So to avoid doing that, I would want to choose a differential element that is a strip, either a horizontal strip or a vertical strip. So I'm going to choose my differential element to be a horizontal strip. So this is my differential element. So it's a rectangle. This total length is x. This point right here has coordinates of x and y. So for this differential element, its width is is dy. Therefore, its area, so this right here, dA equals to x times dy. As you can see, we only need to integrate with respect to one variable in this case. And then what about x tutor? So this is its centroid location. Because it's a rectangle, therefore its centroid location is right there at the center. Easy to determine. Therefore, as you can tell, x tutor, the x coordinate of this point, equals to half of x. So that's this part right here. X tutor equals to half of x. So now we're ready to evaluate x bar. Because we need to integrate the total area, so let's do that first. So the integration of dA, which equals to the total area of this shape, equals to the integration of x times dy, which equals to, remember I evaluate x expressed in y, so x equals to 1 minus 4y squared dy. Now I only have one variable, which is y, and for this entire shape, it is integrated from when y equals to negative 1/2 meter, because the total height is 1 meter and it's symmetric. So it's from y equals to negative 1/2 meter to y equals to positive 1/2 meter. So integrate from negative 1/2 to positive 1/2. And this is the polynomial. It's not that difficult to integrate. So this equals to y minus 4 over 3y to the third power, evaluated from negative 1/2 to positive 1/2. And after the evaluation, this actually equals to 1/3 minus negative 1/3, so 2/3. That's the total area. And then that is the denominator here. And we need to also find the numerator, which is x tutor dA integration. So that equals to x tutor is half x. dA is x dy. So this is actually 1/2 times x squared. So 1/2 is a constant that can be pulled out. So this is 1 minus 4y squared. That's x squared dy. So this equals to 1/2 integration 1 minus 8y squared plus 16y to the 4th power dy. So now you also have polynomial of y. So this is again not that difficult to integrate. This is again integrated from negative 1/2 to positive 1/2. So this equals to 1/2 times y minus 8 over 3 y to the 3rd power plus 16 over 5 y to the 5th power, evaluated from negative 1/2 to positive 1/2. So this eventually is evaluated to be 4 over 15. Therefore, your x bar equals to 4 over 15 divided by the total area, which is here, 2/3. Okay. So this equals to 2 over 5, so 0.4 in the unit of meter. And y bar equals to 0. Therefore, eventually your C, the centroid, is 0.4 meter, 0. So if you try to sketch it on this graph right here, so this is a half, so 4 is right here. Therefore, the centroid is here. Which is a reasonable location for the centroid.